Hey there students, welcome back to DG Tutorials. Today we're diving into the world of grade 12 math, specifically radical functions. Trust me, by the end of this video you'll have unlocked the secrets of these fascinating functions. So, what exactly is a radical function? Well, a radical function is any function that includes a variable within a square root. Imagine y equals sine x plus 5, that's a classic example. Now let's talk about the domain. The domain includes all the possible x values that we can plug into our function. But here's the catch. For a radical function to make sense, the radicand, that's the stuff under the square root, has to be non-negative. You can't take the square root of a negative number and expect a real result. When you're graphing radical functions, you'll notice they tend to form curved lines. These curves are typically wider than they are tall. A key point to remember is that the graph of y equals sine x looks different from its linear counterpart, say y equals sine x. The linear graph is a straight line, while the radical graph curves. But wait, there's more. Sometimes you'll come across radical functions that look like a semicircle. This happens when your function has specific restrictions on its domain and range. On the other hand, functions with absolute values can create sharp V-shaped graphs. It's crucial to understand these differences to master graphing. Let's consider the x-intercepts of radical functions. The x-intercept is where the graph touches the x-axis. These points are the roots of the function, the values of x that make the function equal to 0. For radical functions, the roots can be found by setting the radicand equal to 0 and solving for x. And what about the quadratic? When the quadratic is positive and there's no restriction on the domain of the square root, the graph extends infinitely in the positive direction. This makes the range of the function all real numbers greater than or equal to 0. So to wrap things up, the key takeaways are: understand the domain and range of your radical functions. Graphs of radical functions are curved and wider than they are tall. And always consider the x-intercepts and behavior of the quadratic. Got it? Awesome! Now go ahead and tackle those radical functions with confidence. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell so you never miss out on more grade 12 math tips and tricks. See you next time!